Okay, so the speed of cars on a freeway is normally distributed. So once we know that it's normally distributed, means it's following that bell shape. So I'm going to draw that there. And for a 2-hour period on a certain day, police find motorcyclists exceeding the speed limit of 100 kilometers per hour. They find 150 motorists out of 6,000 and note that the mean speed is 90. So we know down here, because it's bell-shaped, and so the mean would be in the centre, so that's 90. Now, they're asking me what the standard deviation is. So somehow these numbers are going to show. Now, if this is normally distributed, if you just think about 150 out of 6,000 motorists were fined for going over 100. Okay, so if we think what's 150 out of 6,000, and if we make it a percentage, so I'm going to change that to a percentage. So that ends up being 2.5%. So 2.5% of the cyclists were going more than 100. So if you think about it, 100 would be up here. Okay, so here's 100 kilometers per hour. And what they're saying is, we're saying that 2.5% above would be traveling above that. So that means anywhere up here would be 2.5%. Now, if you think of our 68, 95, 99.7 rule, when we see a 2.5% pocket, we know we're sitting at 2 standard deviations. So between 90 and 100, we've gone up 2 standard deviations. So there would be 1 and there's 2. So the distance between 90 and 100 is 10. So if we divided that by 2, it'll equal 5. So 90 at 95 would be at 1 standard deviation away, and at 100 we'd be at 2 standard deviations. So that's how we've worked out the standard deviation is 5. Okay, this one is pretty difficult, so it would be one I'd pop in the reference book.